Hello students, how are you all? Jai Hind, welcome to my YouTube channel. I'm pretty sure students, you must be working real hard, isn't it? And you must be revising all the concepts thoroughly. Students, please don't take any undue stress while studying. Enjoy your studies, right? Yes, getting a good score and graduating from a good college may give you a comfortable life, no doubt regarding that. But it is not the only medium. Students who are average in studies might not cope up with today's pressure. Yet, believe me, they can do well in their respective lives. Right? If they have any other skills which they can work on, they can definitely succeed. Marks could matter. A good college tag, a good placement are important. But not so much for it to be the last thing in the world. Remember this, students. Yes, the school exams, annual exams, unit tests, they are very important. And a person should study all they can towards getting those marks. But always remember, students, that's not the end of everything. Try your best and leave rest to the Lord. Right? So don't ever take undue stress while studying. So with that, students, let's begin today's session. Today we are going to continue with the free body diagrams. So these are the 4 questions in which we will be trying to consider, or rather we will draw the free body diagram of each body and then construct the equations. These are not numericals. With the help of these diagrams, these cases, I will illustrate completely and fully and convincingly so as to how to construct the equations using free body diagram. Right? So let's start with the first question, students. First question is, this is an inclined plane. The plane is making an angle theta over the horizontal. Right? And these are the 2 masses. This is the string over the pulley. And students, remember, in all the questions, the pulleys are considered to be massless and frictionless. And the string is also considered to be inextensible and massless, and the surfaces in contact are also considered to be frictionless. So force of friction is considered to be absent or negligible, right? So in each of the questions, we will try to construct the equations of each of the bodies using free body diagram, right? And in numericals, m1, m2, theta can be given, so you can easily find out the acceleration of the bodies as well as the tension in the string. But you can do so only after constructing the equations. So here in this particular lecture, we will be trying to construct the equations of each of the bodies constituting a system. Right? Let's start with case A. Suppose the system of the body gets accelerated along this direction. Now, as we are aware, students, in the case of fixed pulley, acceleration of the bodies constituting the system is constant. Why? Because we are aware of second equation of motion, S equals to ut plus half at square. Initially, both the bodies are at rest. So what do you get? S is equal to half a t square. Therefore, for a given time, means t is constant, right? So in that case, when t is constant, then a would be directly proportional to displacement. Now in all the cases, if one body moves through a distance of 2 meters, the other body which is attached to the same string will also move through the same distance, isn't it? So, if the bodies cover same distance in a given time, then the acceleration of those 2 bodies must be same, isn't it? So, in this case, if the body of mass m2 has acceleration a in the downward direction, then body of mass m1 will also have acceleration of same magnitude, but in this case it will be up the inclined plane as shown in the figure. Right? So both the bodies constituting the system will have the same acceleration in magnitude. Okay. Now let's draw the free body diagram. Consider for body of mass m1, right? Let's consider body of mass m1. This is the case basically. This is the body of mass m1. This is the inclined plane. Okay. Suppose this is the point where the net mass, entire mass of the body may be assumed to be concentrated. So this can be termed as center of mass. And in case of symmetrical body, center of mass and center of gravity coincides, isn't it? So what are the forces acting over here? One is the weight, that is m1g. It will always act in the vertically downward direction towards the center of the earth, right? Second is reaction. We have discussed, students. Reaction is a force which always acts perpendicular to the surface over which the body is placed. So reaction would be like this. This is the reaction, isn't it? This is the reaction. And this will be the tension. This is the tension. Tension is a force which will act along the length of the string towards the point of suspension. Clear, students? Okay, these are the three forces acting over here. And the acceleration is along this direction. Acceleration of the body is along this direction. So we need to construct the equation using this free body diagram. And moreover, students, what to do is, suppose if we extend it, and this is a vertical line, and this is a horizontal line. Now these two lines are parallel. These two lines are parallel. Therefore, this angle would be equal to this angle. It is theta, isn't it? Now, if you drop a perpendicular to the inclined plane, it will be like this. This is 90 degrees, students. This is 90 degrees, perpendicular to the inclined plane. This is also 90 degrees. So, the remaining angle would be 90 minus theta, isn't it? Now, this is horizontal line and this is vertical line. So, this remaining angle would be theta. Understood, students? So, here, if you resolve this m1g into two components, one in a direction opposite to that of the reaction, so this angle would be theta. I am talking about this angle. This one. So, if you resolve m1g into two perpendicular components, what do you get? This component would be m1g cos theta, while the other component would be m1g sin theta. Isn't it? So m1g has been resolved into two perpendicular components, right? One in a direction opposite to the reaction, the other in a direction opposite to the tension. So these are the two perpendicular components. So students, m1g cos theta, m1g sin theta, these are the two sides of a parallelogram, and their resultant is given by the diagonal of the parallelogram passing through the same point. So as per the parallelogram law, vector addition is valid. So we have resolved m1g into two perpendicular components. So now the diagram is over. So the body is accelerating in the upward direction. So t must be greater than m1g sin theta. T must be greater than m1g sin theta. Am I clear? Tension must be greater than m1g sin theta because the body is accelerating along the direction of the tension. So tension must be the dominating one. Now what is the angle between these two? It is 180 degree opposite directed. So whenever the two vectors are opposite directed, then the resultant force is given by, in magnitude, it's given by the difference in the magnitude of the two vectors. So students, net force, it will be T minus m1g sin theta. This is the net external force acting on this body, right? And as per Newton's second law, net external force is mass into acceleration. So it will be equal to mass. Mass is m1, acceleration is a. So this is equation number 1. So these are the two forces which are balancing each other because the body is moving along this direction. The body is not having any motion along this direction. So R and m1g cos theta must be balanced forces. So they must be cancelling out the effect of each other. So R should be equal to m1g cos theta. This is the second equation. Clear, students? So by drawing the free body diagram, we can easily construct these equations. So this is for body of mass m1. Now let's consider this body of mass m2. For body of mass m2, let's draw its free body diagram. This is m2. So what will be the forces acting over here? One is m2g, which will be the weight of the body, which will act in the vertically downward direction. The other one would be the tension, like this, along this direction. Tension always acts along the length of the string towards the point of suspension, and the acceleration of this body is in the downward direction. This is it. This is m2. So students, obviously, m2g being directed along the direction of the acceleration of the body must be greater in magnitude as compared to the tension, isn't it? And as per Newton's second law, net force acting on a body is equal to mass into acceleration. So what is the net force acting on this body? m2g minus t. Because m2g is dominating, it is along the direction of acceleration of the body. So the equation for body of mass m2 would be m2g minus t. This is the net force acting on the body, and it is equal to mass into acceleration, that is m2 into a. So this is how the equations can be constructed. Now students, in actual numericals, you will be given the value of m1 and m2. Theta would be given. So knowing the value of m1, m2 and theta and constructing, and by using equation number 1 and 3, we can easily get the value of acceleration of each of these two bodies, as well as we can get the value of the tension in this string. So for solving such numericals, you need to draw the free body diagram, and accordingly you need to construct the equations perfectly. And thereafter simply substitute the values given in the numerical, and you will be easily able to solve the equations and get the appropriate answer. Right? So this is how the equations needs to be constructed. Okay, let's proceed with question number 2 then. It's again the case of inclined plane, and as we have already discussed, the assumptions are that the pulleys, they are considered to be massless as well as frictionless, and the surfaces in contact are also considered to be frictionless. That is, force of friction is considered to be negligible, and we'll also consider the string or the thread or the wire to be inextensible and massless. Okay, so let's concentrate on question number 2 then. Okay, overview. Again students, m1g will act in the downward direction like this, isn't it? This is m1g. So if you resolve it into two components, one perpendicular to the inclined plane, so this angle would be equal to this angle, isn't it? This angle would be theta 1. Clear students? Just now previously we have proved it. Similarly, over here, m2g, it will act in the vertically downward direction like this. This is m2g. It will act in the vertically downward direction. And if you resolve it into two components perpendicular to the inclined plane, then this angle, it will be equal to this angle. This is theta 2. Clear? So now let's draw the free body diagram of m1 for m1. Okay, this is the diagram basically. This is the hypothetical point where the entire mass of the body may be assumed to be concentrated, so it may be termed as the center of mass. So net force acting on this body may be considered to be applied at this particular point, right? So what are the forces acting on it? First is the weight, which is m1g. In this case, if we consider the system to be oscillating along this direction, then as you are aware, it is a fixed pulley and the length of the string remains constant. So both the bodies in a given time will cover the same distance. So accordingly, oscillation for both the bodies would be same. So if for this body the oscillation is along this direction, for body of mass m1, it will have the same oscillation up the inclined plane, right? So it will have oscillation along this direction. Now what are the forces acting over here? One is the tension. This is the tension, isn't it? This is the tension. And reaction. Reaction always acts perpendicular to the surface of contact. This is the surface of contact of these two surfaces. So reaction will be perpendicular to it. Students, diagram should be perfect. So do practice. Right? Diagram should be perfect. Now, as I told you, M1G is to be resolved. One component should be balancing the reaction. So it should be opposite to R. So what to do is, this angle, it is equal to theta 1. I am talking about this angle. This is theta 1, this angle. So M1G can be resolved. This component would be M1G cos theta 1, while the other component, other perpendicular component would be opposite to the tension, that is M1G sin theta 1. Clear, students? So that's the free body diagram. Now how to construct the equation then? R and M1G cos theta 1, these are the balanced forces. Body is moving along this direction. So there is no motion of the body along this direction, isn't it? So R must be balanced by M1G cos theta 1. While T and M1G sin theta 1, they are unbalanced forces because the body is having acceleration along this direction. So T must be greater. T must be greater than M1G sin theta 1. The force which is acting along the direction of the acceleration of the body must be dominating one, isn't it? And since these two are oppositely directed, so what is the net force acting on this body? It will be T minus M1G sin theta 1, isn't it? This is the net force acting on this body. And as per Newton's second law, net force is mass into acceleration. What is the mass of this body? M1. What is the acceleration of this body? A. So this is the equation. Right? Similarly, let's try to construct the equation for M2. Okay. It's like this. This is M2. This can be considered the center of mass. This is the weight of the body. It should act in the vertically downward direction. Please, students, you have to draw the diagram perfectly. This is the tension. This is the tension. And reaction force, it always acts perpendicular to the surface over which the body is placed. This is the reaction force, 90 degree, right? So it can be resolved, M1, M2G can be resolved. This is angle theta 2. I'm talking about this angle, this one, theta 2. So M2G can be resolved into two components. This component would be M2G cos theta 2, while this component would be M2G sin theta 2. And the acceleration of the body is along the inclined plane downwards. So this is the free body diagram, right? So let's construct the equation. As I told you, body is accelerating along this direction, isn't it? Body is accelerating along the inclined plane in the downward direction. So the body is not having any motion along this direction. So R and M2G cos theta 2 must be balanced forces. So the reaction must be balancing M2G cos theta 2. Reaction will be different. If this is R, this can be considered to be R dash. Okay. Second is towards these two are unbalanced force because the body is having some acceleration. So some net force is acting on it. And net force is always along the direction of the acceleration of the body, isn't it? So M2G sin theta 2 must be greater than T. So net force acting on this body would be M2G sin theta 2 minus T. This is the net force acting on this body. Why minus sign? Because both these forces are oppositely directed. Whenever the two forces are oppositely directed, then the magnitude of the result is given by the difference in the magnitude of the two vectors under consideration. So this is the net force. It should be equal to mass into acceleration. Mass of this body is m2, acceleration is a. So again, students, if theta 1, theta 2, m1, m2 are given in a numerical, then by using these two equations, we can easily solve and get the value of acceleration of each of the two bodies, which is constant, as well as the tension in the string can be easily evaluated. So I hope you should get confident in drawing the free body diagram as well as in constructing these equations, right? So let's proceed to the third question then. And again I must remind, these are not the numericals. I am only trying to make you familiar with the free body diagram and then constructing the appropriate equations using those free body diagrams. That is very important. Until and unless you are aware to construct the equations using free body diagram, you won't be able to solve such questions, right? So do sufficient practice. Okay, question number C. These are the three bodies. Again, let's consider the acceleration. Suppose it's along this direction. So these are the strings and these are the two pulleys P1 and P2. Both the pulleys are fixed. Therefore, if this body moves down by 1 meter along the inclined plane, this body will go up by 1 meter and this body will move horizontally towards left by 1 meter. So it is but obvious that all the three bodies during the same time will cover same distance. Therefore, all the three bodies will possess the same acceleration. So if this body is having acceleration A, it will also have acceleration A and it will also have acceleration A. Right? Now let's try to construct the equations using free body diagram of mass M1, M2 and M3. So let's start with M1. For M1, like this. Okay, this is the center of mass. Its weight will act in the vertically downward direction. Always remember. Tension. This will be the tension. Suppose this is P. This is another string, so it can be considered to be T dash. This tension can be considered to be T dash, and this string, the tension, can be considered to be T. Right? So tension is acting along this direction. This is T. This will be the reaction strings. This will be the reaction. Suppose it is R1. So we can resolve M1G into two perpendicular components. This angle, as I stated, it will be equal to this angle, that is theta, isn't it? Over here, draw horizontal and over here is the vertical. So if you join this angle would be equal to this angle, corresponding angles. Then again, if you draw perpendicular to the inclined plane, then what happens is this is 90 degrees. So if this is theta, this angle would be 90 minus theta, isn't it, students? And this is horizontal and this is vertical. This is also 90 degrees. So this angle is 90 minus theta, therefore this remaining angle would be theta. So that is what I have done. So M1G can be resolved into two components, one in a direction opposite to the reaction. It will be M1G cos theta, while the other component would be opposite to that of the tension and it will be M1G sin theta. Clear? And the acceleration of the body is along the inclined plane in the downward direction, like this. So students, what will be the equations? This body won't have any motion along this direction. So these are the two balanced forces. So R1 is M1G cos theta. And what about these two forces? They are unbalanced forces because the body is having a net acceleration along this direction. So M1G sin theta must be greater than the tension. So equation would be M1G sin theta minus T. It is equal to M1 into A. So this is the equation. This is the net force acting on this body of mass M1. So net force is equal to mass into acceleration. Clear, students? So this is the equation for body of mass M1. Now let's consider for M2. For M2. Let's draw the free body diagram. This is M2. Right? What are the forces acting? This is T, this is the tension T. The other one is T dash, this is T dash tension. And the other force acting is its weight, that is M2G. Right? M2G. And the body is accelerated in the upward direction. So this is the free body diagram. Clear, students? Now look, what is the net force acting downwards? it is m2g plus t dash. Why plus sign? Because both are in the same direction. When the vectors act in the same direction, they get naturally added up. But T must be greater than the sum of these two forces because the body is getting accelerated upwards. So students, what is the net force acting on this body? It will be T minus m2g plus T dash. This is the net force acting on this body in the upward direction. Net downward force is m2g plus T dash. Net upward force is T. Net force is acting in the upward direction because the body is getting accelerated upwards. Therefore, upward force must be dominating as compared to the net downward force. So, resultant would be T minus inside bracket m2g plus T dash. So, this is the net force acting on this body. And net force is mass into acceleration. What is the mass of this body? It is m2. Acceleration is a. So, that's it. This is the equation. You can put this as equation number 1. You can put this as equation number 2. Right? Let's consider body of mass m3. For body of mass m3, it is placed on a horizontal surface. This is m3. So, one is the weight m3g, reaction force, that is the contact force, right? So here the reaction force will be perpendicular like this. This is the reaction force. It can be considered to be R. Tension, it's acting along this direction, which is T dash. And it is getting accelerated horizontally towards left like this. So here students, the body is having motion horizontally towards left. So it is not having any motion in the vertical direction. So vertical direction, the forces must balance or nullify the effect of each other, and that is possible only when the reaction is exactly balanced by m3g. Isn't it? These two are balanced forces. Must be balanced forces. So what is the net force acting on it? Net force acting on this body is only T dash. These two are balancing or cancelling out the effect of each other. So the net force acting on body of mass m3 is only T dash. And net force, as per Newton's second law, is mass into acceleration. So what is the mass of this body? It is m3. What is the acceleration of this body? It is a. So this is the third equation. So students, if in a numerical theta, m1, m2, m3 are given, then by using equation 1, 2 and 3 and substituting the values of m1, m2, m3 and theta, we can easily get the value of t, t dash and a. So there are three variables, t, t dash and a, and there are three equations which we can use in finding those values. Right? Okay, now the last question is left, students. Question number D. Let's construct the equation after drawing the free body diagram, isn't it? Suppose the direction of the acceleration is along this. So the system is moving like this. These are the two bodies which are connected with the help of that string, right? So as the string is considered to be inextensible and massless, therefore if the body m2 goes down by 1 meter, the body m1 will move towards right through distance of 1 meter. So in a given time, both the bodies will definitely have the same acceleration, isn't it? We are aware for a given time t, acceleration is directly proportional to displacement. So in the case of fixed pulleys, remember students, whenever it is the case of fixed pulleys, these are the fixed pulleys, then the bodies which are connected through a string over that pulley must be having the same displacement in the same given times. Therefore, acceleration of those bodies must be same, isn't it? So, if this body is having acceleration in the downward direction, this body will have acceleration towards right horizontally, right? Let's draw the free body diagram for mass m1, for body of mass m1. Okay, the body is on the horizontal surface like this. So this is m1. What are the forces acting over here? One is its weight. The other one is the reaction force, which always acts perpendicular to the surface over which the body is placed, isn't it? And then this is the tension. tension force always comes into play when a body is suspended through a string or connected through a string. Tension is a force which always acts along the length of the string towards the point of suspension. For this body, this will be the point of suspension. So tension will act along the string towards the point of suspension. For this body, the point of suspension will be this one. So it will act along the string towards the point of suspension. Right? So this is where the tension acts. And the acceleration of the body is along this direction. Now this body is getting accelerated towards right. It is only having horizontal motion and vertical motion is 0. So obviously, in the vertical direction, the body must be under the influence of balanced forces, isn't it? So R must be equal and opposite to M1G. So these two forces must be nullifying the effect of each other, right? So these two forces get cancelled out, being balanced forces. So what is the net force acting on this body? It is only tension. And Newton's second law, students, net force is equal to mass into acceleration. So net force acting on this body is only T, and it is equal to mass into acceleration. So this is equation number 1. Right? So very simple. Okay, let's draw the free body diagram for mass M2. This is the body. This is M2. Right? Suppose this is the center of mass of the body, where the entire mass of the body may be assumed to be concentrated. So what are the forces acting on it? One is its weight, which is obviously M2G. It will always act in the vertically downward direction along the radius towards the center of the earth. It's actually the force of gravity, the force with which the body gets attracted towards the earth. That's the weight of the body. The other one is the tension. And here, students, the body is getting accelerated downward. So definitely M2G must be greater than the tension, isn't it? So it is getting accelerated downward. So M2G must be greater than T. M2G must be dominating one. So what is the net force acting on this body? It would be M2G minus T. Again, why this negative sign? Because both are oppositely directed. The angle between these two forces is 180 degree. And since the body is having acceleration in the downward direction, therefore M2G must be dominating as compared to the tension. So the net force acting on the body due to the opposite direction of these two is given by the difference in the magnitude of these two forces. So this is the net force. And as per Newton's second law, net force is equal to mass into acceleration. So this is the net force, M2G minus T. It's equal to mass into acceleration. Mass of this body is M2. Acceleration of this body is A. So this is equation 2. So knowing the value of M1 and M2 and substituting those values in these two equations, we can easily solve for A as well as we can get the value of the tension T in this string. Right, students? So in this session we have understood how to draw the free body diagram, and most importantly how, with the help of those free body diagram, we can construct the equations so as to find out the acceleration of the body's constant of the system as well as the tension in the string. So students, I will strongly recommend to do numericals based on these concepts, right? So that's it for this particular session. I'll come up with some other interesting numericals this time based on free body diagram, right? So thank you so much for watching this video and keep watching. Do join me in my next lecture then. Thank you.